Right. So the first equation is requiring you to express 6 over 3 plus root 5 plus root 14 in the form a plus b root c plus d root e, where a, b, c, d, and e are real numbers, 3 marks. Right. So this is very simple. What you need to do here is you need to apply the skill of rationalization. So 3 plus root 5 plus root 14. So let me combine 3 with root 5. Then I rationalize by multiplying both the numerator and the denominator by 3 root 5 minus root 14. 3 plus root 5 minus root 14. It's more of a conjugate. Right. So what I'm going to do here is 6 is going to multiply the numerator. Then on the denominator, I'm going to apply difference of 2 squares. Right. So 6 times 3, you get 18. You write 18 here. Then 6 times root 5, you get 6. Root 5, something like this. Then 6 times minus root 14, you get minus 6 root 14. I hope you are following class. Right, then on the denominator, we apply a difference of 2 squares. So I'm going to target the side with a minus. So the first term is 3 plus root 5, which I'm going to raise by power 2. And the second term is root 14, which I'm going to raise by power 2 using the difference of 2 squares. Right. So on the above, I'm going to leave the terms like that, since we do not have like terms. So 18 plus 6 root 5 minus 6 root 14 cannot be reduced any further since they are not like terms. So let me expand below. Right. So 3 raised by power 2, you get 9. Then to find the middle term, I'm going to say 3 times root 5 times 2. It gives you 6 root 5. Then the last term here, it's root 5 squared, which gives you 5. I hope you are following. Then minus root 14 squared, you get minus 14. Let us simplify the denominator. So this is 18 plus 6 root 5 minus 6 root 14. Then you say 9 plus 5 is 14. 14 minus 14, you get 0. So you are going to be left out with 6 root 5 on your denominator. So we can rationalize it further if we multiply by root 5 on both the numerator and the denominator. I hope you are following class. Right. So 18 times root 5, you get 18 root 5. Then 6 root 5 times root 5, you get 6 dot product of 5, since root 5 times root 5 is 5. Then minus 6 times root 5, you get minus 6 open bracket. This 14 is going to multiply 5. I hope you are following class. Then we move on to the denominator. 6 root 5 times root 5, you get 6 dot product 5, since root 5 times root 5 is 5. So it simply means you now have 18 root 5 plus 30, which is 6 by 5, minus 6 root 70. Then on the denominator, 6 times 5, it gives you 30. Right. The order being required by the question is A plus B root C plus D root E. So I'm going to start with the number without root sign, which is 30. So let me write 30, right, plus 18 root 5 minus 6 root 70. Then you distribute the denominator 30 right? So I'm going to distribute or divide each and every term above by 30. I hope you are getting it, class. So 13 to 30, it's 1, right? Then 18 over 30 can be reduced by 6, where 6 into 18 is 3, 6 into 30 is 5, giving you 3 over 5 root 5. Then 6 into 6 is 1, 6 into 30 is 5. So you now have 1 over 5 root 70. And this is the form A plus B root C plus D root E being required, where A is 1, B is 3 over 5, C is 5, D is 1 over 5, and E is 70. So this is how you're supposed to attack this question. I want you to stay tuned as we move on to question number 2. It reads, solve the inequality 10 minus 2x over x minus 2 is greater than x plus 1, 4 marks. Right. So what I'm going to do is, firstly, majority of the candidates, they cross multiply, which is wrong. Why? Because x minus 2, we have the value of x which is unknown. So if we cross multiply, we do not know whether x minus 2 is negative or it is positive. Remember, if you multiply by a negative number, the inequality sign is reversed, right? So if you cross multiply, it is wrong. So the best way is to move x plus 1 to your left side. You get 10 minus 2x over x minus 2 minus x plus 1 is greater than 0. And you put x plus 1 in brackets, something like that. Right. So the next task is to express the left-hand side as a single fraction, where your LCM is the product of x minus 2 and 1, giving you x minus 2, something like this. X minus 3 into x minus 2, you get 1. So if you multiply 1 with the 10 minus 2x, you get 10 minus 2x. Then you put a negative sign. 1 into x minus 2, you get x minus 2. And this x minus 2 would then multiply x plus 1 above. Then you put a greater than sign, something like this. Right. So we now want to expand on our numerator. You get 10 minus 2x. Be very careful. On this one, you must put a big bracket. Why? Because this negative sign is going to multiply all the terms that are going to come out when you multiply x minus 2 and x plus 2. Right, so here you get x squared minus 2 plus 1, it's minus 1. So the middle term is minus x. Then minus 2 times 1, you get minus 2. So remember, if you have got x here and x there, you simply find the two terms or the two factors which gives you sum or difference of the middle term. So minus 2 plus 1, you get minus 1. This is your middle term. But if you multiply those numbers, they give you the last term. So this is a shortcut which works if you have got x here and x there. Right. I'm going to divide by x minus 2. Then you put greater than 0, something like this. Now that we are through multiplying x minus 2 with x plus 1, you can safely introduce the negative sign. This is going to give you 10 minus 2x minus x squared. Minus and minus, you get plus x. Minus and minus, you get plus 2. All over to x minus 2. So let me put an equal sign because we want to identify the critical values. Right. Collecting like terms, you are going to get minus x squared, right? Minus 2x plus x, it gives you minus x. 10 plus 2, you get 12. Then over x minus 2 is equals to 0. Right. So this equation is simple to solve especially when the coefficient of x squared is positive. So I want to make the coefficient of squared positive by multiplying both sides with -1. But if you do that, this inequality sign is going to be reversed. So you now have x squared, since this -1 multiplies the numerator alone, so it gives you x squared plus x minus 12 over x minus 2. Then 0 times -1, you get 0. But what I'm trying to say is the fact that you have multiplied by -1 both sides, the inequality which was greater, it becomes lesser. It changes direction. I hope you are following class. Right. So if we factorize on our numerator, you put x here, then you put x there, then you have x minus 2 is equals to 0. Right. We want to find the two factors of -12, which gives you a sum or a difference of 1 and a product of -12. And those factors we have +4 and -3. Right. So those three brackets on your left side, they are going to assist you to identify your critical values. So you now have x plus 4 is equals to 0, or x minus 3 is equals to 0, or x minus 2 is equals to 0, something like this. So your first critical value is -4, and your second critical value is 3, and you have 2. Right, so let us put those critical values on number line. Right, so now that we have prepared the number line, we now want to test the acceptance region. Right, so let me choose 0 first. 0 is in this region, the second one. We now want to substitute 0 on inside the brackets to test whether the left hand side is going to be lesser than 0 for this region to be true. Right, so if we put 0 on x plus 4, you are going to be left out with 4. If you put 0 on x minus 3, you'll be left out with -3. Then if you put 0 on your denominator, you'll be left out with -2. 4 times -3, it gives you -12, divided by -2, which is 6. So remember, our region is less than 0. It was greater before, but since we multiplied both sides by -1, the inequality was reversed to become lesser than 0. Right, so is it true for 6 to be less than 0? No, it is not true, but it is false. So this region is going to be rejected. Right, so if you reject this region, the adjacent regions are automatically accepted. So you accept the neighbors, left and right. Right, then you reject. There is a pattern which always comes out. If you accept, you reject the next. You accept, you reject the next. If you reject the first, you accept the second. You reject the third, you accept the fourth. So you follow that pattern. So now that we rejected -4 less than x less than 2, it means we automatically accept the neighbors. Then you reject the last region. Right, so my answer is going to be presented in this way. X is less than -4. Good. Union 2 less than x less than 3. And this is your final result. This is how you work it out. I want you to stay tuned as we move on to question number 3. It reads, given that f is equals to k s squared, where k is a constant, find the percentage change in f if s increases by 5%. Right, so firstly you need to understand the required percentage change in f. Percentage change in f, it simply means delta f over f times 100. So this is the way you write percentage change in f. It's delta f over f times 100. This delta f, it means small increment or a small change in f. I hope you are following. It is the required, so this is the unknown or the required. Then we are also given that s increases by 5%. It means delta s over s times 100 is equals to positive 5. Since they are saying increases by 5%, so you don't write 5% on the right side. Since you have multiplied by 100, just write 5. So I want to make delta s the subject of the formula. Is equals to 0,05, dividing both sides by 100. Then delta s is equals to 0,05 s if you multiply both sides by s. So you keep this. We are going to substitute it later. Right, then after that you move to the original formula. F is equals to k s squared. Then make use of this formula to find df ds. So 2 times k, you get 2k. Then you less 2 with 1, you are going to be left with s to the power of 1, which is good as s. So you get 2ks if you differentiate. Right, so the f over the s is approximately equal to delta f over delta s. Right, so I'm going to take 2ks, which is approximately equal to delta f over delta s, something like this. So remember, we have made delta s the subject of the formula, and we got 0,05 s. So it means 2ks is approximately equal to delta f over 0,05 s. Then you cross multiply. So if you cross multiply, what is 2 times 0,05? You get 0,1 k s squared is approximately equal to delta f, something like this. Right, so remember the requirement is the percentage change in f, which is delta f over f times 100. So delta f, we found it to be 0,1 k s squared. So I'm going to write 0,1 k s squared on delta f. Then you divide it with f, where f is equals to k s squared. So I'm going to divide by k s squared. Then you multiply by 100. So k s squared and k s squared, they cancel off each other. So it's 0,1 times 100. You get 10%. So 10% is your final result. I hope you are following class. So let us move on to question number 4. Right, question number 4 reads, use the trapezium rule with the 4 trapezia of equal width. So trapezia of equal width, they are referring to intervals or stripes, right? To estimate the value of integral of 1 over x e to the power of 1/3 of x, giving you answer to 4 decimal places, 4 marks. Right, so let me write the formula first. A is equals to h over 2. Good. Then you write y1 plus y last plus twice the rest. Inside this big bracket, you add the first y ordinate with the last y ordinate. Then you add with twice the sum of the remaining y ordinates. So h, which is the height, is found by the formula upper limit minus lower limit divided by number of stripes. right? So your upper limit is 2. So you write 2 minus 1 over number of stripes. So number of stripes are good as the number of trapezia. But if the question said use trapezium rule with the 4 ordinates, to find the number of stripes, you say number of ordinates minus 1. I hope you are following. So this question is not saying 4 ordinates. So you are going to take 4 as it is, since 4 is good as the stripes, which are the trapezia. So I'm going to put 4 here. So 2 minus 1, you get 1. Then divide 1 with 4. It gives you 0.25, which is your height. I hope you are following, class. So if you substitute 1/4 on h and divide it by 2, you are going to be left with 1 over 8. Then this is y1 plus y last plus twice the rest. So it means h over 2 is good as 1 over 8 by dividing 1/4 with 2. I hope you are following, class. Right, so I'm going to prepare a table. On my left side, I'm going to place x ordinates. Then on my right side, I'm going to place y ordinates. So let us start with x1. What is x1? x1 denotes the lower limit. And our lower limit in this case is 1. So x1 is 1. Then you use this height, 0.25, as your common difference. Like in an AP sequence, if you add the common difference, you are going to find the next term. So the next term here is x2, which is good as 1.25 after adding 0.25 on our lower limit. Then to find x3, you add 0.25 on 1.25, it gives you 1.5. To find x4, you add 0.25 on 1.5, you get 1.75. Then to find x5, you add 1.75 with the 0.25, it gives you 2, which is your upper limit. So I want you to notice something. If you have got 4 stripes are going to give you 5 ordinates. 4 trapezia are going to give you 5 ordinates. I hope you are listening. So to find y1, you substitute x1 on x. So you are saying 1 over 1. You put 1 on x, e to the power of 1/3 times 1. You get 1/3. This is your first term. So if I punch this in my calculator, e to the power of 1 divided by 3 to 4 decimal places, it gives you 1.3956, something like this. Then we move on to x2. x2 is 1.25. So you are going to put 1.25 on x. You get y2 is 1 over 1.25 e to the power of, if you multiply 1/3 with 1.25, you get 1.25 over 3. So let us punch this in our calculator. 1 divided by 1.25 exponential to the power of 1.25 divided by 3 to 4 decimal place, it gives you 1.2135, something like this. Then we move on to x3. x3 gives you y3 as 1 over 1.5 e to the power of 1.5 over 3. So if you punch this, you get 1 divided by 1.5, second function exponential to the power of 1.5 divided by 3. You get 1.0991. So you write 1.0991. Then we move on to y4. It's 1 over 1.75 exponential 1.75 over 3. So we are saying 1 divided by 1,75 exponential 1,75 divided by 3. You get 1,0240. 1,0240. Then move on to y5. It's 1 over 2 exponential of 2 over 3. So we are saying 1 divided by 2 exponential to the power of 2/3. You get 0,9739. Something like this. Right, so substituting it in this formula, you get your area as A is equals to 1 over 8, open bracket. Your first y-ordinates is 1,3956 plus your last 0,9739 plus twice the rest. So the rest they are referring to the sum of the remaining ordinates. So I'm just saying 1,2135 plus 1,0991 plus 1,024. The total is 3,3366. So 3,3366 is the sum of the remaining y-ordinates. So let me punch this at once. Get 1,8 open bracket 1,3956 plus 0,9739 plus twice the rest. The sum of the rest is 3,3366. You get 1,1303. So 1,1303 is your final answer to 4 decimal places, which is the requirement of the question. So this is how you're supposed to do to attack this question. Now moving on to item 2, it reads, explain whether the trapezium rule is underestimated or overestimated the value of this integral. Here you will be assisted by the nature of the graph, the exponential graph, where the power is 1 over 3x. I hope you are following. Right, so the curve, it comes like this. So this is the curve. It increases as x increases towards the infinite side. Right, so if you draw your sketch, you can clearly notice that the upper part of the trapezium, right, is above the curve. The upper part of the trapezium is above the curve. So if the upper part of the trapezium is above the curve, it means the trapezium is including the shaded part, which is above the curve and not under the curve. Hence, we say trapezium rule overstates the value of this integral because it includes the area above the graph. A single mark for writing that statement. Right, so stay tuned as we move on to question number 5. Right, we are now on question number 5. It reads, P is a fixed point on the circumference of a circle with center O. Right, so when attempting such questions, sketching is good. So let me draw the circle with center mentioned O, and they are saying P is a point which is lying on the circumference of that circle. Let us proceed. And radius 5 centimeters. So distance from O to P is given as 5 centimeters, and that distance is fixed. So you need to understand that 5 centimeters is representing a fixed radius, which is not going to change. Right. Another point Q moves around the circumference. So let us put Q on the circumference of the same circle at a constant speed of 3 centimeters per second. So let me connect POQ. The angle POQ is theta radians. So this is theta. And the length of arc PQ is x centimeters. So they are saying the distance from Q up to P is x centimeters, something like this. Right. Find the rate of increase of theta. So if they are saying the rate of increase of theta, it means Q is moving in this direction, so that we open up this angle. So as Q is moving downwards, this angle increases. I hope you are following. Right. So how do you find the rate of increase of theta? So you need to write the rate of increase of theta as a differential coefficient first. So you say d theta over dt, because we increase theta with respect to time. Then we are also given in the question that Q moves around the circumference of the circle at a constant speed of what? Of 3 centimeters per second. So if Q is moving at a constant speed of 3 meters per second, it simply means this value of x is going to increase with the same speed as Q is moving. So we are simply saying the x over dt is also going to increase by 3 meters per second as Q moves by 3 meters per second. This is going to increase the arc. I hope you are following. Right, then we are given R as 5, which is your fixed radius. Right. So how do you find d theta over dt? You need to write x in terms of theta. Remember, the formula for length of arc is r theta. So you write x is equals to r theta. I hope you are following. Then you find the x, d theta. And remember, r theta is good as 5 theta since the radius is fixed as 5. So derivative of 5 theta, it gives you 5. Then you apply chain rule to find d theta over dt. You are saying dx over dt, this differential coefficient multiplied by the reciprocal of dx d theta, which gives you d theta over dx, so that dx and dx, they cancel off each other to give you d theta over dt. Right, I hope you are following. So dx over dt is 3. You write 3 multiplied by reciprocal of dx over d theta. Since this one is 5, it means reciprocal is 1 over 5. You get 3 over 5. And this is your rate of increase of theta with respect to time. I hope you are following, class. Let us move on to item 2. Find the rate of increase of area of sector POQ. So let us write the expression. Area of sector is half r squared theta, and r is 5, so you get half r squared 5 squared theta, which gives you a is equals to 25 over 2 theta. Then you find the a over d theta, and the a over d theta is going to give you 25 over 2. I hope you are following. Now that we have the a over d theta, we now want to find the rate of increase of area. So the rate of increase of area is dA dt, because the area, it increases with respect to time. So I'm going to write dA over d theta. Then you multiply with a differential coefficient where d theta cancels off with d theta to get d a over dt. So the best coefficient to use is the answer in part 1. In this one, we are not going to reciprocate it, but we are going to take d theta over dt as it is, so that d theta and d theta, they cancel off diagonally to give you dA over d theta. So dA over d theta is 25 over 2 times d theta over dt, which is the answer in part A, and this answer is 3 over 5. So 5 into 25, you get 5. 5 times 3, it gives you 15 over 2. Therefore, your answer is 7,5. Right, so you can say 3 over 5 radians per second, since the theta is in radians. And this is 7,5 square meters per second, since area is measured in square centimeters. Right, so question number 6, it reads, express 2x cubed minus 17x minus 1 over x minus 2 in brackets, x squared plus 5 in brackets, in partial fractions, 6 marks. So whenever you attempt a question which involves partial fractions, do not be quick to prepare the identity. I hope you are following. You know, this one is a linear factor and this one is a quadratic factor, but do not be quick to prepare the identity. Why? Because sometimes or in most situations, long division must be done first before you create the identity. So what you need to do when attacking a question in line with partial fractions, you compare the powers, the highest power of the numerator with the highest power of the denominator. If the highest powers are equal, or if the denominator has got a lesser power, it means carry out long division first before you prepare the identity. In this case, you can notice that if you are to remove brackets on your denominator, the highest power that you are going to get is x cubed, yet x cubed is a factor of x cubed. So it means you need to carry out long division first before the identity. I hope you are following. So let me expand this first. X minus 2, x squared plus 5. We want to expand this. You get x times x is x cubed, right? Then x times 5, you get 5x minus 2x squared minus 10. I hope you are following. Right, so after expanding, you carry out long division. So you are saying x cubed minus 2x squared plus 5x minus 10 divided by, this is 2x cubed minus 17x minus 1, but I'm going to write it as 2x cubed plus 0x squared minus 17x minus 1. This helps me to align like terms. I know there is no term in x squared. So if there is no term in x squared, you can represent it by 0 x squared, simply for alignment of like terms. So x cubed into 2x cubed to get 2. Then multiply all these 4 terms by these 2. So 2 times x cubed to get 2x cubed. 2 times minus 2x squared to get minus 4x squared. 2 times 10, 2 times 5x you get plus 10x. 2 times minus 10, it gives you minus 20. So let us subtract. 2x cubed minus 2x cubed to get 0. Then minus and minus, it gives you plus. So 0 plus 4, you get 4x squared. Then minus and plus, you get minus. So it's minus 17 minus 10, it gives you minus 27x. minus and minus, you get plus. So 20 minus 1, you get plus 19. I hope you are following. Right, so this one represents what you call your remainder, since we cannot simplify it any further. Right, so you are going to say 2x cubed minus 17x minus 1 over x minus 2 x squared plus 5 is equals to 2, this 2, right, plus, then you write remainder 4x squared minus 27x plus 19 all over 2 x minus 2 x squared plus 5. Right, so 4x squared minus 27x plus 19 over x minus 2 x squared plus 5. I'm going to express this into partial fraction. Then after that, I place 2 on the answer as your first term. I hope you are following. Right, so you are saying 4x squared minus 27x plus 19 all over 2 x minus 2 x squared plus 5 is identical to, so x minus 2 is a linear factor, so you write a over x minus 2 plus x squared plus 5. Since it is a quadratic which is irreducible, it is a quadratic factor, so you write bx plus c, which is the numerator for quadratic factors. It's bx plus c. Divide it with x squared plus 5. I hope you are following. Right, then x minus 2 into this LCM, you get x squared plus 5. So x squared plus 5 is the one attached to a. Then you write bx plus c. You are saying x squared plus 5 into x squared into the LCM, you are going to be left out with x minus 2. And this is identical to 4x squared minus 27x plus 19. Right, so we want to eliminate letters. So let's say when x is equals to 2, you get 2 minus 2, and this entire bracket bx plus c x minus 2 becomes 0, so that you find a. So you get a, open bracket, 2 squared plus 5 is equals to 4, open bracket, 2 squared minus 27, open bracket, 2 plus 19. So 2 squared plus 5, you get 9. So you have 9a on your left. Then on the right side, it's 4, open bracket, 2 squared minus 27, open bracket, 2 plus 19. You get minus 19. So divide both sides by 9. A is equals to minus 19 over 9. Then after that, you want to find b. You can say, you want to find c. You can say let x be equals to 0. So if you put 0 on x squared, you are going to be left out with 0 plus 5, which is 5a in that bracket. Then b disappears. You'll be left out with c in the first bracket, and in the second bracket you'll be left out with minus 2 if you put 0 on x. 4x squared and minus 27x, they become 0. If you place 0 on x, you'll be left out with 19 on your right side. So since a is now known as minus 19 over 9, you substitute minus 19 over 9 on a minus 2c is equals to 19. Then you are saying 5 minus 19 over 9 minus 19 is going to be equivalent to 2c, moving 2c to the right and 19 to the left. So let me punch this in my calculator. 5 open bracket minus 19, remainder 9, right? Then you less minus 19, what do you get? Minus 266 over 9 is equals to 2c. So divide both sides by 2. It gives you minus 133 over 9 is C. Then to find B, you can equate the coefficients of x squared. A times x squared, you get ax squared. It simply implies a is a coefficient of x squared. Then if bx multiplies x, you get bx squared. So b is another coefficient of x squared. Then on my right side, we have 4x squared. So you write 4, representing the coefficient of x squared on your right. Right, so a is minus 19 over 9 plus b is equals to 4. Therefore, b is equals to 4 plus 19 over 9. So 4 plus 19 over 9 get 55 over 9. B is equals to 55 over 9. Right. So after carrying out long division, we got 2 plus 4x squared minus 27x plus 19 over x minus 2x squared plus 5. Right. Then we expressed this second term into partial fractions using the identity a over x minus 2 bx plus c over x squared plus 5. Now that we have calculated the constant terms a, b, and c, we are now substituting the constant terms on a, b, and c, but your final answer is going to contain these two first before you substitute the values of a, b, and c. So you are going to write 2, then you put plus. What is the value of a? In our calculations, we got a as minus 19 over 9. So I'm going to write minus 19 over 9 divided by x minus 2. Then we move on to b. B is 55 over 9. So you say plus 55 over 9x. There is x here in front of b. Then how about c? The value of c is minus 133 over 9. So I'm going to write minus 133 over 9 on c. Then you divide this by x squared plus 5. I hope you are listening. So we can simplify it further. Plus and minus, it gives you minus 19 over 9 over x minus 2 plus, here you can factor out 1 over 9 is the highest common factor of 55 over 9 and 133 over 9. So you are factoring out minus 1 over 9. You get 55 x minus 133 all over 2 x squared plus 5. Right. So the denominators like 9 here and 9, they can be brought down. It means your final answer becomes 2 minus 19 over 9 open bracket x minus 2 plus 55x minus 133 over 9 open bracket x squared plus 5. So this is your final answer. Right, so I want you to stay tuned as we move on to question number 7. Right, we are now on question number 7. It reads, the table shows the values of a variable p obtained experimentally from the values of q. So this topic is in line with our linear law, right? The variable P and Q are related to the by the relation log P is equals to B log Q plus log A. I hope you are following. So according to linear law, log P represents Y. So Y is equals to mx plus C. So log A is representing C, the y-intercept. B is your gradient, which is M. Log Q is your x. And log P is your y. So you simply prepare a new table of values, which is in line with this relation or this equation. Right. So I'm going to have log Q to represent the x values. Then log P is representing the y values below. So how do you find how many columns do you have? 4. So 1, 2, 3, 4. So to find the first 4 values of x, you simply take these integral values 2, 3, and 4 and 5, and you place them in front of log. So I'm going to substitute log 2. It gives you 0.30. So I'm going to write 0.30 here. Then log 3, it gives you 0.48. This is 0.48. Then log 4, it gives you 0.60. 0.60 here. Then log 5, you get, if you round, it gives you 0.70. Right, then we move on to log P. Log P is representing the y value. Since log P is the subject, you are going to find log 3.55. Log 3.55, you get 0.55. So I'm going to write 0.55 here. Then log 1.3, log 1.93, you get 0.29. So you write 0.29 here. Then log 1.26, you get 0.10. I'm giving them two decimal places. Then log 0.90, you get negative 0.05. So this is negative 0.05. Right, so I'm going to find a suitable scale which suits this table of values. Then we plot it on a graph paper. Right, so I have decided to make use of 2 centimeters to represent 0.1 unit on both axes. So we are going to plot the first set. The first set is 0.3 for x and 0.55 for y. So this is 0.3 for x, 0.55. It's 5 boxes above 0.5. So 1, 2, 3, 4, 5. This is the point. Let me mark it. So this is our first point. Then we move on to the next. You have 0.48 against 0.29. So 0.48, you have 8 small boxes in front of 0.4. 1, 2, 3, 4, 5, 6, 7, 8 here against 0.29. So we need how many boxes? 9 boxes above 2. Something here. You have 9 boxes. Then we move on to the next. 0.60, which is good as 0.6 against 0.10. which is good as 0,1. So this is 0,6 here, 0,1 here. You put your point there. Then you move on to the last one. You have 0,70, which is 0,7 against 0,05. But this is negative 0,05. So 0,7 is there, but minus 0,05 is below the x-axis, which is our log Q. So 5 boxes below 0. So you are saying 1, 2, 3, 4, 5, and this is your point here, right? So you take your ruler and connect all those 4 points. So this is the outcome of the graph, how it is supposed to come out like, right? We move on to part 2 of the question. Determine the approximate values of A and B, right? So to find, let me start with B. Remember, B is the coefficient of log Q, where log Q is our x in this case. So B is representing the gradient. So B is equals to y2 minus y1 over x2 minus x1. I hope you are following. So you can choose any 2 points of your choice which are lying on the line that you have drawn. So I'm going to choose 3 and 0,55 against 0,6 and 0,1, something like this. Then you substitute into the formula. So this is x1, y1, x2, y2. You get 0,1 minus 0,55 over 0,6 minus 0,3. Divide by 0,3. You get negative 1,5. This is your gradient, which is the value representing B, right? Then we move on to A. So to find A, you choose a pair of your choice here from the 2 points. Then you substitute in this equation. Since our graph is not cutting the y-axis, it was going to be simple to find the value of A if your line was cutting the y-axis. The value or the y-intercept where the line cuts or meets the y-axis was going to represent log A. So in this case, even if we are to proceed this line, they are not cutting. So we are going to use substitution method. So according to substitution method, I'm going to start by writing the equation first. Our equation is log P is equals to B log Q, right, plus log A, something like this. So I'm going to use 0,6 to represent log Q, 0,1 to represent log P. So on log P, let us put 0,1. Then B is the gradient, which is minus 1,5. We found it in part A. Open bracket. On log Q, put 0,6. Right, we want to find or to make log A the subject of the formula. So negative 1,5 times 0,6, you get negative 0,9. So it's now 0,1 plus 0,9 is equals to log A. After moving negative 0,9 to the left, you get plus 0,9. So if you add it with the 0,1, you get 1 is equals to log A. I hope you are following, class. So remember, a log without a base is in base 10. So you simply take 1 and you raise 10 by 1 so that you make A the subject of the formula. 10 to the power of 1 is 10. So A is 10, and this is your final answer. Right, question number 8, it reads, part A, it is given that f of x is equals to px squared plus 5x minus 4. Find the set of values of p for which f of x is positive for all real values of x, 2 marks. So to find p, you need to choose the appropriate discriminant. This is in line with the discriminant, right? So if the question says positive for all real values of x, they are not referring to real roots. I hope you are following. But they are just saying your graph is above the x-axis where the positive values of y are found. So in simple terms, your curve or your graph is not intersecting with the x-axis. This implies that your px squared plus 5x minus 4 is positive here, is positive for all real values of x. So for whatever value of x which is on the number line, if I insert it into the f of x, you are going to get the value of y which is positive. So it means the graph is not intersecting with the x-axis. So positive for all real values of x, it means we have imaginary roots. We do not have any real value of x. So the discriminant being required is that of imaginary roots, which is b squared minus 4ac is less than 0. I hope you are following. So remember, b is the coefficient of x. In this case, the coefficient of x is 5. So you write 5 squared, right? Minus 4. A is the coefficient of x squared. In this case, a is p. Then c is the constant term, which is minus 4, is less than 0. So you get 25, right? Minus and minus, you get plus. 4 times 4 times p, it gives you 16p. It's less than 0. So you now have 16p is less than negative 25. Then you divide both sides by 16. So the range or the set of values of p is p less than minus 25 over 16, and this is your final result. So do not confuse the statement positive for all real values of x with the real roots. For real roots, we use b squared minus 4ac is greater than or equal to 0. This is used as the discriminant in a situation where real roots are stated. Then distinct and real roots, real and distinct roots, we make use of b squared minus 4ac is greater than 0. Then if they are perfect double roots or repeated roots, we make use of b squared minus 4ac is equal to 0. But for this one, we use the imaginary one. I hope you are following. Let us move on to part 2 of the question. It's the remainder when 4x to the power 4 minus 5x squared minus 13x plus 3 is divided by x plus b is equal to the square of the remainder when 2x squared minus 3 is divided by x plus b. Calculate the possible values of b correct to 2 decimal places, 4 marks. Right, so it simply means that to find remainder, you say f of, since they are saying x plus b, the remainder is found by f of minus b. I hope you are following. So you are going to put minus b on x. So you get 4, open bracket, minus b to the power 4, minus 5, you put minus b, this is squared, then minus 13, you put minus b on x, plus 3. So this is the remainder when the first function is divided by x plus b. So they are saying that remainder of the first function is equal to the square of the remainder if the divisor, right, divides 2x squared minus 3. So you are saying is equals to the square. You put 2 first, open bracket, minus b squared. We are substituting minus b on 2x squared, then minus 3. Then the entire bracket is going to be raised by power 2, so that the remainder of the second function is squared for it to be equal to the remainder of the first function. I hope you are following, class. Let us proceed. Right. So when a negative number is raised by an even power, the negative sign disappears. So here you are going to be left with b4, then minus 5 b2, since negative disappears with this even power 2, minus and minus, you get plus 13b plus 3, something like this. Right, then we move on to the right side. Let us first simplify the inner terms. This is 2b squared minus 3 raised by 2. So you have 4b4 minus 5b squared plus 13b plus 3 is equals to. So the first term is going to be found by raising it with power 2. So 2 squared, it gives you 4. B squared, it gives you b4. The middle term, you say 2b squared times minus 3 times 2. You get minus 12 b squared as your middle term. Then the last term, you raise minus 3 with power 2. It gives you plus 9. I hope you are following, class. Right. So what happens is equal terms appearing both sides, they cancel off each other. Meaning to say 4b4 and 4b4 are going to set off each other. Then I'm going to move minus 12b squared and plus 9 to the left, so that this right side remains with 0. So you have 12b squared, this negative 12b squared, if it is moved to the left, it becomes positive, which is a like term with minus 5b squared, which is on the left side already. Then plus 13b plus 3, which is going to be a like term with minus 9 if we move plus 9 to the left. Then you leave the right side with the 0. So 12 minus 5, you get 7. So this is 7b squared, right? Plus 13b. 3 minus 9, you get what? Minus 6 is equals to 0. So using the quadratic equation, b is equals to minus, our b in this equation is 13, so you write minus 13 plus or minus square root b squared, you say 13 squared minus 4, a is 7 and c is minus 6. Then you divide by 2a, where 2a is 27. So b is equals to minus 13 plus or minus 2 times 7, below you get 14. Then if you punch 13 squared minus 4, 7 and minus 6, you get 37. So we are going to split it to have two solutions. Minus 13 plus square root of 337 divided by 14 is our first solution, or minus 13 minus square root of 337 divided by 14. So if we punch the first one in our calculator, you are saying negative 13 plus square root of 337. You say equals, then you divide by 14. You get 0.38 to 2 decimal places required by the question. So 0.38 is your first solution. Or minus 13 minus square root of 337 equals divided by 14 minus 2,24. So you write minus 2,24. So these are the solutions. This is how you go about it. Right, we are now on question number 9. Question number 9 is in line with the factor 1. So we are given a triangular prism labeled already, right? But there is a special note here. MP NP is equals to 5 units. So MP from here to this point, they are saying it's 5 units. We have 5 units here. Then NP, where is NP? From N to P, we also have 5 units. I hope you are following. O is the midpoint of MN. This O is the midpoint of MN, right? OR is equals to 9J plus 4K. It means for someone to move from this point O to R, you are going to move in the J direction up to the midpoint of SQ, right? Which I'm going to label T, right, as the midpoint of SQ, not in the diagram, but we are generalizing, right? So this line is your 9J, right? Then plus 4K. Remember, K is the vertical direction from O to P, which is also good from the midpoint, which is T, towards to R. They are saying this is 4K. So you get 9J, this stretch, plus 4K downwards. This is OR, right? So if O to T is 9J, it simply means we also have 9J here. We also have 9J for MS, 9J for NQ, as well as 9J for PR. I hope you are following. Then if TR is 4K, it means from O to P, we also have 4K, since OP is equal to TR. I hope you are following, right? So we want to find PS. We can say PO. We can say PO first plus. So this is PO from P to O plus OM. So you're going to write OM, then plus MS. Say plus MS, something like this, right? So what is PO? PO is negative 4K. Since 4K is heading downwards, PO is heading upwards. Whenever your opposite direction, a negative sign is introduced. So on PO, I'm going to write minus 4K. Right. We now want to find OM. Right. So we are given by the question that the modulus from M to P is 5, and the modulus from P to N is also 5. It simply means that you can make use of Pythagoras theorem to find the modulus of O to M. So you are saying 5 squared is now acting as your hypotenuse to this point, is equals to 4 squared plus modulus of O M squared, something like this. So 5 squared is 25. 4 squared is 16. It's equals to modulus of OM squared. So this is 9 is equals to modulus of OM squared. Then you put square root both sides. It simply means modulus of OM is equals to 3. So we have 3i. From O to M, we have 3i. So I'm going to say plus 3i here. Then from M to S is good as O to T. So this is plus 9J. So when writing our answer, we start with I first, 3i, followed by 9j, and lastly minus 4k. So this is our PS. I hope you are following. Right, so to find the unit vector, remember unit vector is the vector itself divided by its modulus. So the unit vector now is calculated as follows: 3i plus 9j minus 4k, right, all over 2 square root of 3 squared plus 9 squared plus minus 4 squared. So 3 squared plus 9 squared plus minus 4 squared, you get 106. So this is 3i plus 9j minus 4k divided by square root of 106. I hope you are following. So our final answer can be written as 3 over square root of 106i plus 9 over square root of 106 j minus 4 over square root of 106k. This is our unit vector. I hope you are following. We move on to the next question. Calculate angle SPQ. Right, so to find SPQ, you need to make a sketch first, which might not be on the diagram itself, but you can make your own sketch here. We want to find SPQ. So P is the angle, this is S, and this is Q. So we now have PS, right? PS is 3 plus 9j minus 4k, which can be written as 3, 9, and minus 4 using the column vector. This is PS, right? So to find the angle, we need PS and PQ. So let us identify PQ. What is PQ? To find PQ, you are going to move from P to R. So PQ is equals to P to R plus R to T plus RT, then plus T to Q. So plus TQ. So this is the route to find PQ. So what is P to R? P to R is 9j, which is this stretch. Then R to T is negative of 4k. Something like this. Then TQ, since we now know that this is 3 here, it simply means that O was the midpoint of MN as mentioned by the question, that O is the midpoint of MN. So if you have 3 on OM, you have 3 on ON, which is also 3 on TQ. But for TQ, you are now moving opposing the I direction. So instead of saying 3I, you say minus 3I for TQ. So for TQ, we are now moving opposing this I direction. So instead of saying 3I, you say minus 3I, since you are opposing this I direction. So write minus 3I for TQ, something like this. Right, so minus 3I plus 9j minus 4k is representing PQ. So you write minus 3, 9 here, and minus 4. I hope you are following, class. Right. Then you write cos theta is equals to dot product of 3, 9 minus 4 minus 3, 9, and minus 4 divided by their modulus. So this is 3 squared plus 9 squared plus minus 4 squared. And here you have minus 3 squared plus 9 squared plus minus 4 squared. So you are now writing cos theta is equals to 3 times minus 3, you get minus 9. 9 times 9, it gives you 81. Minus 4 times minus 4, you get positive 16. I hope you are following, class. Right, then you now need to simplify the root signs. So the modulus of PS, we got it already in part A. It was square root of 106. So you are simply putting 106 here. Then if you look clearly, we have same numbers. Though here is 3 squared and minus 3 squared. They are all the same. So 394, 394, they still give you 106 if you punch it in your calculator. So to find the angle, you are now saying cos theta is equals to negative 9 plus 81 plus 16. You get 88 as your numerator. Then root 106 times root 106, it gives you 106. So theta is equals to arc cos of 88 over 106. What do you get? Arc cos of 88 divided by 106, you get 33,88, which is good as 33,9 degrees to 3 significant figures. So this is your angle. I hope you are following. I want you to stay tuned as we move on to question number 10. Right, we are now on question number 10. It reads, the complex number z satisfies the equation z plus 2 conjugate of z. If you see the line, one line above z, it means conjugate of z. So they can use a line, a bar, or they can use a star. It simply means conjugate of z. Right, but if you have two lines, they represent conjugate of conjugate. I hope you are following. Right. Is equals to 13 over minus 2 plus 3i. Find z in form of x plus iy, 3 marks. Right. So let me represent z with x plus iy, the required form. I am going to substitute x plus yi on z in the above equation. You get x plus yi on z plus 2 open bracket. We have conjugate of z in front of 2. So for conjugate, you simply convert this plus into minus. So it's now x minus yi is equals to 13 over minus 2 plus 3i. I hope you are following. Let us remove the bracket on the left. You now have x plus yi plus 2x, right, minus 2yi, something like this, is equals to 13 over minus 2 plus 3i. I hope you are following. Collecting like terms, x with 2x, it gives you 3x. Then yi minus 2yi, you are going to get minus 1 yi, which is good as minus yi, is equals to 13 over minus 2 plus 3i. I hope you are following. So you've got two options here. It's either you now solve the left side, multiplying both the numerator and the denominator by the conjugate. So this is now minus 2 minus 3i over minus 2 minus 3i. This is the right side. Then you keep the left side as it is. 3x minus yi is equals to, so 13 times minus 2, you get minus 26. Then 13 times minus 3i, you get minus 39i. I hope you are following, class. Then on your denominators you apply the difference of two squares. So I'm going to target the term with minus in between. So the first term is minus 2, you raise it by power 2, then you put the negative sign, then 3i is also raised by power 2. Maintain the left side as it is. 3x minus yi, good, is equals to minus 26 minus 39i. Minus 2 squared is 4, right? Then you put minus, right? 3 squared, you get 9 I squared. But take note that I squared is equivalent to minus 1. So since I squared is minus 1, we now have 4 plus 9 as our denominator, which is 13. So maintain the left side as it is. What is 4 plus, this is minus 26 minus 39i. We now have 13 since I squared is minus 1. So 13 into minus 26, you get minus 2. Then 13 into 39, you get 3. So this is 3i. Then on the left side, you have got 3x minus yi. So we are now equating real terms, right? So the real term on the left is 3x. The real term on the right is minus 2. This is the first equation for real terms. Then on the right side, I'm going to equate the imaginary terms. The imaginary term on the left is minus y, which is the coefficient of I on the left, is equivalent to minus 3, which is the coefficient of I on the right. So from the imaginary side, you can tell that y is equal to 3 as the negative signs, they cancel off each other. Then on the left side, x is equal to minus 2 over 3. So since they want you to give your answer in the form x plus iy, you simply substitute the value of x and the value of y in the form. So I'm going to put minus 2 over 3 on x plus iy, which is good as 3i, since y is equal to 3. And this is your final answer. You are home and dry. Let us move on to the next part. Right. Find the modulus and argument of 1 over z. Right. So since this is our z, right, they want you to find the modulus of 1 over z. So in simple terms, the modulus of 1 over z is good as modulus of 1 divided by modulus of z. I hope you are following. So you can start by calculating the modulus of z using the z that we got in part A. This is minus 2 over 3 squared plus 3 squared. So you get 2 remainder 3 squared plus 3 squared. What you get? You get 85 over 9 here, which is simply good as square root of 85 over 3 is the modulus of z. Right, so modulus of 1 or a modulus of a constant term is the constant term itself. So modulus of 1 is 1. Then modulus of z is root 85 over 3. And to simplify this, you just reciprocate your denominator. So your final answer is 3 over square root of 85. I hope you are following, class. Right, then we now want to find argument of 1 over z. So argument of 1 over z is simply good as argument of 1 minus argument of z. More of laws of logs. If you divide, you subtract. Same applies if you want to find argument of zw, argument of z plus argument of w. So when multiplying, you add, but when dividing, you subtract. So here we need arctan of 1 minus arctan, right? Z, you are saying 3, the number in front divided by minus 2 over 3, the number which is before, right? So what is arctan of 1? Arctan of 1, it gives you 45. So I'm going to write 45 here minus arctan of 3 divided by minus 2 remainder 3, our denominator. You get negative 77,47. So if you are getting negative 77,47 degrees as the argument of Z, it needs to be adjusted. Why? Because the coefficient of the imaginary part, which is plus 3, it determines whether your answer is going to be plus or minus. So in this case, we have plus 3. So it means our angle must be a positive angle. So this one now represents a principal value, but not the final argument of Z. So you need to adjust it by adding it with 180. So I'm going to add by 180 so that the angle becomes positive. You get 102,5. So I'm going to less 45 with 102,5 degrees. So if you less, what do you get? Negative 57,5 degrees. This is the argument of 1 over Z. Then you are home and dry. I want you to stay tuned as we move on to question number 11. It reads, in a geometric series, the ratio of the sum of the first 4 terms, right, to the sum of the first 2 terms is 17 over 16. Right. By the way, what is the formula to find sum of a GP? This is the question now. To find sum of a GP, we make use of the SN formula for GP, which is A, open bracket, 1 minus R to the power of N divided by 1 minus R. This is the formula. Then to find the terms, we make use of AR to the power of N minus 1. So they are saying sum of the first 4 terms, which is S4 in this case, is equivalent to 17 in terms of ratio. I hope you are following. So they are saying sum of the first 4 terms to the sum of the first 2 terms, right, is equals to 17 S to 16. I hope you are following. So I'm going to find S4. You are saying A 1 minus R to the power of 4, placing 4 here, divided by 1, is it minus R? Good. Equate this to 17. Then you say A, open bracket, 1 minus R squared over 1 minus R. Equate this to 16. I hope you are following class. Right. So since we have 1 minus R above and 1 minus R below, we can simply reduce the left side by ignoring 1 minus R. Since we have A above and A below, we can reduce the left side by ignoring A. So A and 1 minus R are now out. They don't affect the ratio. I hope you are following. Right. So you are now left with 1 minus R to the power of 4 divided by 1 minus R squared is equals to 17 over 16. I hope you are following. Then if you look clearly, we can do something here. If we apply difference of two squares on the numerator, square root of 1 is 1, square root of r4 is r squared. Here you write 1 plus r squared over 1 minus r squared is equals to 17 over 16. So you can notice that 1 minus r squared and 1 minus r squared, they cancel off each other, leaving you with 1 plus r squared is equals to 17 over 16. All right. So we now want to make r squared the subject first. You move 1 to the right side. So now you have 17 over 16 minus 1. So 17 over 16 minus 1, it gives you 1 over 16. So r squared is equals to 1 over 16. Then take root sign both sides. Square root here and square root here. We normally put plus or minus. So r is equals to plus or minus 1 over 4. But you look at the question to check whether there is a condition set for r, like this one. They are saying r must be greater than 0. It is a condition. So of the two values of r that we have got, it means we are now ignoring the negative part. So the only answer of r is 1/4, where 1/4 is the one which is greater than 0. So this is the first part of the question. I hope you are getting it, class. Let us move on to part B. Given that the third term is 2 and 3/4. Remember, for terms, we make use of un is equals to a r to the power of n. So they are saying u3, which is your third term, is equals to a. We now know that r is 1/4. So I'm going to put 1 over 4 on r. Then since we have got 3, that means here we now have 3 minus 1. They are saying this third term is equivalent to 2 and 3/4, something like this. Right, so it means a 1/4 squared is equals to, if we express this as an improper, this is 4 times 2 is 8 plus 3, you get 11 over 4. You now have a is equals to 1 over 16, since the power 2 raises both the numerator and the denominator, is equals to 11 over 4. Right. Then to find a, divide both sides by 1 over 16. So it's now 11 over 4, right? Divided by 1 over 16. So 11 over 4 divided by 1 over 16, you get 44. So it means our first term is equals to 44, which is our A, right? But this is not the requirement of the question. The question is requiring you to find the sum to infinity. So sum to infinity is found by the formula A divided by 1 minus R. This is the formula. So now that we now know that A is 44, you divide 44 with 1 minus 1/4, which is good as 44 divided by 3/4. So divide this by 3/4, you get 58 and 2/3. And this is your sum to infinity. Then you are home and dry. So this is how you do it. Stay tuned as we move on to question number 12. Right, we are now on question number 12. It reads, it is given that e to the power of minus 3y, open bracket 1 minus 4x, is equals to 7 plus 3x. Show that y is equals to minus 1/3, open bracket, ln 7 plus 3x minus ln 1 minus 4x are 2 marks, right? So let us start by dividing both sides with 1 minus 4x. So you can clearly see that 1 minus 4x and 1 minus 4x, they set off each other, leaving you with e to the power of minus 3y on your left, and 7 plus 3x over 1 minus 4x on your right side. Good. Then take or introduce ln both sides. You are now introducing ln both sides. You have ln e to the power of minus 3y is equals to ln 7 plus 3x minus ln 1 minus 4x. Remember, for logs, if you divide, you subtract, right? Then bring this power down. You get minus 3 ln e is equals to ln 7 plus 3x minus ln 1 minus 4x. So ln e is good as 1. So you'll be left with minus 3y on your left is equals to ln 7 plus 3x minus ln 1 minus 4x. So divide both sides by minus 3 or multiply both sides by minus 1/3. You will be able to prove. So minus 1/3 times minus 3, you will be left with y is equals to minus 1 over 3 ln 7 plus 3x minus ln 1 minus 4x, and this is your final answer shown. Right, let us move on to part B. Hence obtain the Maclaurin expansion, right, of y up to and including the term in x cubed, right? So to write up to x cubed, you can visit your data booklet. First, you go to the expansion of Maclaurin under ln. Right, so you can make use of the data booklet or the list of formulas. Ln 1 plus x is equals to x minus x squared over 2 plus x cubed over 3. This is under Maclaurin series, right? Another way was to find dy dx, then you find second derivative, then you find third derivative, then you make use of the formula f of x is equals to f0 plus first prime of 0 x plus second prime of 0 x squared over 2 factorial plus third prime of 0 x cubed over 3 factorial. It is also good, but I think this one can be a shortcut, right? So it only works if you have a positive 1 here, right? So here we have got 7 plus 3x. It means ln 7 plus 3x. We need to factor out 7 first. You'll be left out with 1 plus 3x over 7, something like this, after factoring out 7 to create the required 1. Then applying the product law of logs, you can split it to give you ln 7 plus ln 1 plus 3x over 7. I hope you are following, right? Then I'm now substituting 3x over 7 on each and every term in x. You get ln 7 plus here you are going to substitute on this one to find this term. So x is 3x over 7 minus 3x over 7 squared over 2 plus 3x over 7, this is cubed, over 3, you get, so this is representing ln 7 plus x. Then we also have ln 1 minus 4x. So the good part of this one, it contains the required 1 here. So there's no need for you to factor out anything. You just substitute minus 4x on x. So you get minus 4x substituted on x. Then write minus open bracket minus 4x squared divided by 2 plus minus 4x, this is now cubed, divided by 3 is equals to cubed. Right. So let us substitute our answers in this y. You get y is equals to minus 1 over 3 open bracket. This is ln 7 plus 3x. We found it to be ln 7 plus 3 over 7x minus 9 over 98 x squared plus 9 over 3 43 x cubed. Then you put the negative sign here. So for you to substitute ln 1 minus 4x, you first of all put an open bracket, because this negative sign is going to multiply the terms of ln 1 minus 4x. And these terms are minus 4x minus 8 x squared minus 64 over 3 x cubed. Then you put your big bracket. Right. So y is equals to minus 1/3, right? Open bracket. Ln 7 plus 3 over 7x minus 9 over 98 x squared plus 9 over 3 43 x cubed. Then remove the bracket. This is now plus 4x. Negative times negative plus 8x squared. Negative times negative plus 64 over 3 x cubed. So we want to simplify like terms. Let us start by placing constant terms. The constant term that we have is ln 7. So 3x, 3 over 7. 3 over 7 is a like term with 4x. So I'm going to add plus 4. What you get? 31 over 7. Right, we move on to the terms in squared. Minus 9 remainder 98 is a like term with 8. So plus 8. What do you get? 75 over 98. So you say plus 75 over 98 x squared. Then 9 over 343 is a like term with 64 over 3. So plus 64 over 3. You get 21 979 over 1029 x cubed. Then you are now multiplying every term inside by negative 1/3. So you get negative 1/3 ln 7 as your first term. Then this one becomes negative 31 over 21x. Since 3 by 7 you get 21. Right, then 1 over 3 times 775 remainder 98 you get 775 over 294. So this is negative 775 over 294 x squared. Then negative times negative get plus. So this is now 21,979, remainder 1029. Good, times 1, remainder 3. What you get? You get 21,979 over 3087 x cubed, and this is your final answer. So this is how you're supposed to do it. Right, we are now moving on to question number 13. It reads, use the binomial expansion to simplify x plus 2 to the power of 7 minus x minus 2 to the power of 7 6 marks. Right, so let me expand them independently first. I'm going to start with x plus 2 to the power of 7. So you are saying 7, 0 here. The first term I'm going to raise it by the number below. Then the second term I'm going to raise it by the difference between the two numbers in the bracket. So the difference of 7 and 0 is 7. Right. We are done with the first part. Move on to 7, 1. Right. So x is going to be raised by 1, whereas 2 is going to be raised by the difference. In this case, it's 6. And lastly, we have 7, 7. It gives you x to the power of 7 and 2 to the power of 0. Right, so 7, choose 7. It's more of you are saying 7 combination. 7, choose 0. You are saying 7 combination of 0. You get 1. X to the power of 0, it's 1. So you'll be left with the 2 to the power of 7. And what is 2 to the power of 7? So 2 to the power of 7, you get 128. Then 7, choose 1. It's good as 7. So you are saying 7, choose 1 times 2 to the power of 6. 448. So you get plus 448x. Then you move on to the next term. It's 7. Choose 2 times 2 to the power of 5. 672. So this is 672 x squared. Then you move on to 7. Choose 3. 2 to the power of 4. 560 x cubed. So I write plus 560 x cubed. Then lastly, 7, choose 7 is 1. 2, 0 is 1. So lastly, you'll be having this is x is 7. So this is the answer for the first one. Right, then I'm now expanding the second one, which is x minus 2 to the power of 7. Right. So same applies. You have 7, choose 0, x 0 minus 2 to the power of 7 plus 7, choose 1. This is x1 minus 2 to the power of 6. Good. Then 7 choose 2. You have x squared and minus 2 to the power of 5. To the power of 1, and the last term is 7 choose 7, which is x to the power of 7 minus 2 to the power of 0. All right, so I want to align the terms with the answer above to then find or figure out the final answer. That's why I've left out this space, so that I want to then align the like terms, right? Negative 128, you get minus 128. You write negative minus 128, right? So you can notice that if you punch 7 choose 1 times minus 2 to the power of 6, you are going to get 448, right? Like what we did on 7 choose 1 and 2 to the power of 6, we got 448. But the idea is, for even powers, your answer is plus. For odd powers, your answer is negative. That's the concept, right? So here was an odd power, right, which was 7, right? That's why it remained negative. But on this one, I'm going to get 48x, right, since 6 is an even power. Then on this one, it is going to be negative of the answer that we got above. So this is negative 672 x squared, and this one is going to be positive. So it means you have 560, right, x cubed, yes it is. Then we move on to this one. This one is going to be negative of the answer or the coefficient. You have negative 280 x to the power 4. Then this one is even, so it's going to remain positive. So you have positive 84 x to the power 5. How about this one? This one is odd, so it's going to be negative 14x to the power of 6. And this one, you have 1 here. This is 1, so this one is going to be positive x to the power of 7. Something like this, right? So since we are lessing the two, we are now deducting like terms. So 128 minus 128 is good as 128 plus 128. You get 256. This is your first term. Then 448x minus 448x, you get 0. Then minus and minus here, they become plus. So it simply means 672 plus 672. You get 1344x squared. Then this one is going to give you 0. 567 and 560, you get 0. Then minus and minus, you get plus. So it's simply 280. We are saying 280 times 2, you get 560. So this is plus 560 x4, and this one is 0. Minus and minus, you get plus. So this one becomes 28 x6, x7 minus x7, this one is 0. So your final answer becomes 256 plus 1344 x squared plus 560 x to the power 4 plus 28x to the power of 6. This is your final answer. Then you are warm and dry. I hope you are following class. So I want you to stay tuned as we move on to the second part of the question. Right, hence use the answer in 1 to find the exact value of square root of 5 plus 2 to the power of 7. minus square root of 5 minus 2 to the power of 7. So you can simply tell that we are putting root 5 on each and every x term that we found in part A. We are simply putting root 5. So our answer becomes 2, this is now item 2, right? 256 plus 1344 root 5 squared plus 560 root 5 to the power of 4 plus 28 root 5 to the power of 6. So if we are to punch this in our calculator, you get 244.76, and this is your final answer if you punch that in your calculator. Right, we are now moving on to question number 14.